Hello, in this video I'm going to talk about how you can rationalize the denominator of a fraction when it is a surd. There's a few basic rules really to memorize here. For instance, if you have the fraction 1 over root a, basically what you're going to want to do here is multiply the top and bottom by root a. So in other words, we had 1 over root a, we're going to multiply that by root a over root a, okay, and then basically these cancel out, and so what you end up with is root a over a, okay. The basic principle, or the key intuition I suppose when it comes to rationalizing, is that you want to get rid of the surd in the denominator, okay. You want to move it up into the numerator. So when you're given say the second rule is, say if you're given 1 over a plus root b, okay, the key idea here is you want to multiply, just as we did here if we had 1 over root a. We want to multiply, but we're going to take the negative in this case of root b. So in other words, if we had 1 over a plus root b, we're going to want to multiply that by a minus root b, okay, over a minus root b. You want to take the opposite of whatever this sign is, to put it very simply. And so in that sense what we're left with is a minus root b over, and then these of course cancel, okay, and then that would be a times a, so it would be just a squared minus b, because that's a negative times a positive, okay. The third rule actually relates to this one, and it's not even a separate rule. It's just going to state that states that if you have 1 over a minus root b, then you're going to want to multiply this by a plus root b, okay, so in order to rationalize it. Make that a little bit more neat. A plus root b, okay, over a plus root b. Okay, that's all that really you need to know and memorize when you're rationalizing. So this would just simplify to a plus root b at the top, and it would cancel out of course, and then that's a negative, so it would be a squared minus b, okay. So let's do a few examples. Start with something really simple, and it shouldn't take long to get a grip of the key intuition to understand how to rationalize. If you have 1 over, say, root 11, okay, so just as we talked about previously, you have 1 over root 11, you're going to want to multiply this by root 11 over root 11, which is going to equal root 11, and then they cancel out, right? So it's going to be root 11 over 11. Do another example. Say for instance we have 1 over root 2. This is actually a really good one. You'll likely see this quite a lot. For instance, in trig, you may already make the connection in your minds, but this is a 45, 45, 90. Okay, special right triangle. It's going to be root 2, 1, and 1. If you were to take the sine, the angle 45, which is obviously opposite over hypotenuse, you'll end up with 1 over root 2. Okay. I recall several instances when dealing with trig equations and things like that where you didn't actually have to rationalize this. It was considered entirely correct to leave it this way. But a lot of the time you will also be asked to rationalize, and it's just good to get in the habit of rationalizing anyway, I think personally. So 1 over root 2, what you're going to do, as we know, is we're going to multiply this by root 2 over 2, okay, those cancel, so you end up with root 2 over 2. Do something different. Say we have root 3 over root 15. So how do we go about this? Well, the first step, again, just as we've been discussing and reflecting on, is we're going to want to multiply this by root 15 over root 15, okay? It's going to cancel, and what you're going to end up with is root 3 times root 15 over 15. However, we can still simplify this a bit more. Root 3 times root 15, that's just going to leave us with root 45. Okay, and root 45 is going to leave us with 3 times root 5. If you don't understand how or why that is, say we have 45, just draw a factor tree, okay? 9, oops, got ahead of myself. 5 times 9 is 45, right? And then that's a perfect square, so 3 and 3, so you pull a 3 out. So it's going to leave us with 3 root 5 over 15. And yet we can still simplify this even more. Basically 3 is a common factor here, so we can just divide by 3. So it's just going to leave us root 5 over 5, right? Because 15 divided by 3 is 5. Do something again, it's a little bit different. Say, I don't know, say we have 1 over 2 plus root 5, okay? Well, we know already, 1 over 2 root 5, that we're going to want to multiply this by 2 minus root 5, 2 minus root 5 over 2 minus root 5, okay? So that's going to leave us with 2 minus root 5 in the numerator, and then 2 times 2 is 4, right? 2 times 2, 4, and then it's just going to cancel, so it's going to be 4 minus 5. And this is actually going to leave us with an interesting result, because what this simplifies to is 2 minus root 5 over negative 1. Then we can't stop here. What we want to do is distribute this negative 1. Okay, another way to think about it is distribute the negative sign. So this is going to become a negative 2, right? Positive becomes negative. So it's going to be negative 2. Negative times negative is just positive. So it's going to be negative 2 plus root 5. We'll do 2 more. Think of something different. Say, for example, we have root 3 minus root 7, and all of that's going to be over, just say, root 3 plus root 7. Okay, so it's the same principle in practice, right? We've got our root 3 minus root 7 up top. All of that's over root 3 plus root 7, and we're going to want to multiply all of this by root 3 minus root 7, right? So it's going to be multiplied by root 3 minus root 7. Root 3 minus root 7. What this simplifies to is, if we write it this way, root 3 minus root 7, that's being multiplied by root 3 minus root 7. Okay, all of that's going to be over, well, we know that these are just going to cancel, right? And so in that case, what we end up with is 3, and then this is a positive times a negative, so it's going to be 3 minus 7, okay? And then up here we can still simplify all of this. You can think of the FOIL method if you wish, right? It's just the distributive property. That's how I like to think about it. So root 3 times root 3, that's just going to leave us with 3. Root 3 times negative root 7 is minus root 21, right? 7 times 3 is 21. Likewise, negative root 7 times 3 is minus root 21. And negative root 7 times negative root 7 is just going to be 7 plus 7. Okay? And then all of that, and here we know that 3 minus 7 is negative 4. Or think of it as negative 7 plus 3. And we can still simplify this further. So negative root 21 minus root 21, that's just going to simplify to minus 2 root 21. Okay? Minus 2 root 21. And then, so we can rewrite this. So we've got a 3 plus a 7, right? So that's going to give us 10. And we've got our minus 2 root 21. All of that's going to be over negative 4. And we can now simplify this a bit more, it looks like. Common factor of 2 here. Okay, so just say we're going to divide everything by 2. So that's going to just be 1, so just a negative 1. 2, that's going to be a 5. And that's going to be a minus 2. Okay, so what we end up with is 5 minus root 21 over negative 2. And we're done. I'll do one more. Just a variation of the previous example. Let's say we have, I don't know, root 5 plus root 2. That's going to be over root 5 minus root 2. Okay, so we already know what the first step is. We're going to have our root 5 plus our root 2 over... Actually, I'll write it a little bit different, so you can see it. So we can think about it a little bit different. And we can just kind of write this as root 5 plus root 2. Okay, and that's going to be multiplied by, well, we're going to multiply this by root 5 plus root 2, aren't we? So this is just going to be multiplied by root 5 plus root 2. And at the bottom, we've got our root 5 minus root 2. And that's going to be multiplied, as we just said, by root 5 plus root 2. Okay, you can think of the FOIL method. I mean, at the bottom, this is just going to cancel. Yeah, so I'll try not to skip too many steps. So we've got at the top, we know we've got our root 5 plus our root 2 times our root 5 plus our root 2. At the bottom, this is all just going to simplify, right? The 5's will cancel out. It's going to be 5, and that's a negative root 2 times a positive root 2. So it's going to be 5 minus 2. Okay? So symbols or signs, square root sign there, it's just going to cancel. And then for the top, the numerator, we can just again use the distributive property. We can simplify this further, or if you would like, you can think of the FOIL method, like so. Okay, so root 5 times root 5, that's just going to leave us with 5. Root 5 times root 2, we can just write this as root 5 root 2. Likewise, root 2 times root 5, we can just write this as root 2 root 5, and then root 2 times root 2 is just plus 2. Okay, and then 5 minus 2 is 3. 5 minus 2 is 3. And we can now simplify this even further. So root 5 times root 2 is just root 10. Likewise, here it's just root 10, right? Root 2 times 5, root 5, root 10. And root 10 plus root 10 is the same as saying 2 root 10. Okay, so all of this can then be simplified as we've got a 5 here and a 2, so 5 plus 2 is 7. And then it's going to be plus 2 root 10. Okay, root 10 plus root 10 is just 2 root 10. And then all of that over 3. And it doesn't look like we can simplify this any further, so I'll just box it off. And we're done.